Hello and welcome to our second video on probability. I'm Mr. Chowdhury and today we're going to be looking at the probability of single events with specific focus on mutually exclusive events. So here's a diagram that we looked at the end of the last video, and if you haven't watched that, I suggest you go and watch that first. And the first thing I'd like you to do is pause the video and tell me what the probability of picking a blue counter is. What's the probability of picking a blue counter? Pause the video, have a think. Okay, let's have a look. Well, there are 1, 2, 3, 4, 5, 6 blue counters out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 counters total. So that would be 6/10, 0.6 or 60%. Hopefully you got that right. And before we move on, I think it's really important that we quickly recap the things that we talked about in our last video. So the first thing we talked about was mutually exclusive events. A mutually exclusive event is an event that cannot happen at the same time. So events that cannot happen at the same time. So for example, you cannot roll a 4 and a 3 on a dice at the same time. If you're rolling one dice, you can't roll a 4 and a 3. So the rolling of a 4, that event is one event, and the rolling of a 3 is a separate event. Okay, so now let's look at some other things we recapped. We said that an event was an observation or an outcome. Probabilities can be written as fractions, decimals, or percentages like we have done here, and that mutually exclusive events sum to 1 or 100%, depending on whether you're using fractions and decimals or you're using percentages. Okay, one more thing that we didn't look at that's really important is notation for probability. So notation for a probability looks something like this. So if you see P and the word blue in brackets, that means the probability of picking blue. So if I wanted to write this question, I could have written P of blue equals, and that's one way of doing it. Right, so now let's have a look at probabilities of single events. So I've got a dice here, and we're going to try and find the probability of single events. Well, to find the probability of single events, which we've already been doing but haven't made very explicit, is, well, we take the number of desired outcomes and we write it as a fraction, or we divide it by the total number of outcomes. Okay, so you take the number of desired outcomes, the outcomes that we want, and we divide it by however many outcomes there are. Now you can leave that answer as a fraction, a decimal, or a percentage, as we said previously, and that's how you would work out any probability of a single event. So let's have a look. What if I wanted to find the probability of 2? So P bracket 2 means the probability of rolling a 2 on this dice that I've got there. Well, pause the video and have a go at answering these two questions, and then I will tell you what the answers are in a second. Okay, so now let's have a look at these questions and how we could answer them. Well, how many 2s are there on a dice? How many 2s are there on a dice? Well, on a dice, there is only 1 2 on a dice. There's 1 2, and there are 6 other numbers on that dice. There are 6 other possible outcomes. So what we would write is the following. So we know that there is 1 2 out of 6, which would be 0.16 recurring, or 16.6% as my probability. So the probability of getting a 2 is 1/6. There is 1 2 out of 6, and this is what it is as a decimal, and this is what it is as a percentage. Now let's have a look at the odd number. Well, it's the same kind of principle. How many odd numbers are there on a dice? Well, the odd numbers on a dice are 1, 3, and 5. So there are 3 odd numbers on a dice out of 6 possible outcomes. So then we say that there is 3 out of 6, which is a half, which is 0.5 or 50%. Okay? So all we're doing is taking the outcomes we want. So the outcomes we're trying to figure out. So in this first question, the case was how many 2s are there? What's the probability of me rolling a 2? That's the outcome I want. That's the desired outcome. And we divide it by the total number of outcomes. How many outcomes could there be? What values could come up on a dice? Well, that's the numbers 1 to 6. So there are 6 possible outcomes. And then we write that as a fraction, and then we can convert it to a decimal or a percentage. Okay, so here's what I'd like you to do now, is pause the video and answer these two questions. So the question on the left, all you are doing is looking at the diagram and trying to fill in the table accordingly. There are 10 counters here, And on the right, you are making your own diagram from the information you are given. So pause the video and have a go at that, please. Okay, so I'm just going to go through the answers. I'll put the answers up first, and then I'll go through how to get each one. So I'll put the answers up first, and I'll go through how to get each one. So there are the answers, and I'm going to go through the left-hand diagram first. For the left-hand diagram, there is one red counter out of 10 counters total. There is one red counter out of 10 counters total, which means there is 1/10 probability of getting a red if I was going to pick from these counters. So that means that as a decimal, that would be 0.1. Now let's have a look at the blue ones. There are 2 out of 10, which is 0.2. The yellow ones, there are 4 out of 10, which is 0.4. And the green ones, 1 out of 10, which is 0.1, like we said previously. And 2 out of 10, which is 0.2. And we can check if we've got the right probabilities, because if I add these decimals together, I get 1 as a total, which means, as we know previously, that mutually exclusive events sum to 1. The probabilities of mutual exclusive events sum to 1. So we've done this one correctly. We can see very clearly that it is 4 out of 10. 4 out of 10 is 0.4, because I've got 4 yellow counters out of 10 counters total. Now for this one, I just picked 10 counters to make my life easier. I could have picked 20, in which case I just have to double each of the values. It doesn't matter about the number of counters. What matters is that the probability stays the same. So do I have 2 out of 10 red counters? Yes, I do. I've got 2 out of 10 red counters. Do I have 1 out of 10 blue counters? Yes, I do have 1 out of 10 blue counters. And so on and so forth, until we know the probability of picking the counter in our diagram is the same as what it is in the table. So before we finish this video, it's been a very short one, the key things to remember are the following facts. Mutually exclusive events cannot happen at the same time. So for example, I cannot, if I'm picking one counter, there is no way I can pick a blue one and a red one at the same time. They are mutually exclusive. They only happen on their own. The second thing to remember is that mutually exclusive events, the probabilities sum to 1. As you can see in our two tables, both tables, the sets of probabilities sum to 1. So as long as you remember those two things and remember how to find a probability, which is like we said in the last slide. So if you look at the last slide, we said the probabilities are the number of desired outcomes divided by the number of total outcomes. Now hopefully that's been helpful. You can now go off and watch Mr. Amoson's videos. If you're feeling super confident, you can go on Dr. Frost and Corbett Maths. Go be productive, and I'll see you in the next video.